Solve an equation by factoring. So I'm not going to talk as heavily about why these would be set up in parentheses and then equal 0, because the assumption is that you've watched the other video and that in order to solve a quadratic or something with a second degree here, the only way that's going to happen is if you have the product of two numbers being 0. So let's see what's going on in a couple of these factoring problems. Rewrite the original problem in one. Okay, all of the x's are on the left already. I recognize that this has a squared term. This isn't a one variable linear equation. This is a one variable quadratic function. And it's set equal to 0, so it's not like I have to shuffle things around at all. And I look at this and I'm like, well, that's a 1, 2, 3 term deal. And usually when we had these trinomials, we didn't do that grouping method where we parted the things to the left and the right. We didn't simply just pull out the greatest common factor. This was one where we had to say, what are the factors of -6 that add up to 5. And I'm writing that in red just for the visual. Only pause this video and write that down if you need to. And the factors of -6 that would add up to 5, well, it would have to be 6 and 1. And then I have to figure out if it's going to be a positive 5, well, the 1 over here would be negative. Because 6 times -1 does give me -6. But then 6 plus a -1 gives me 5. What if I would have assumed incorrectly and tried -6 and +1? Well, then those would have added up to -5. So if I can jump right into writing this in factored form, I would have x plus 6 times x minus 1 is 0. And this is a new layer to these problems, but I can still do my check. X squared, okay, all right there, 6x, -x, well, that gives me 5x. And then 6 times -1 does give me a -6. With these nicely factored, I can set up my two equations where I'd say x plus 6 is 0, and then my other one would be x minus 1 is 0. And sometimes I like to write those both out so that I have them figured and don't leave a portion out. So subtracting 6 from both sides, x will be -6, and then adding 1 to both sides on the other equation, x is 1. I can box these, but because there are two solutions, I still like to summarize it as x equals -6, comma 1. I am actually thinking about listing the order of these numbers in increasing order, but you really can just write 1 comma -6. And again, this is not in parentheses because that would be an ordered pair. And yeah, you probably could have cut out this step because these are pretty straightforward by this point, because you'd be like, well, that's got to be -6. That has to be 1, but I'm still showing you these because it won't always be that cut and dry. Okay, I'm going to clear this page. Go ahead and rewrite the second equation. I'm going to show you what's incorrect. Now, the temptation might be to pull a factor of x out from the two terms on the left side of the equation, where you'd then have equals -28 on the right. Well, no matter what you do, I mean, maybe this could be 7. And then this could be 4. I'm just guessing two numbers that would multiply and give me a -28. But really, you're going to be out of luck because that's going to take a lot of trial and error to try to get down that path. So the point being this, that is incorrect because what you need to recognize is that these are problems with a variable to a second degree, and you have to be a little bit more creative in your thinking early on. Now normally these have 0 on one of the two sides. So the easiest way for me to get 0 to one side of this is by adding 28 here and adding 28 on the other side. I've written this 28 below something with a variable x, but I know I can't combine those. So over here I'm going to have 0, and then I'm going to have x squared, which I write further to the left to give myself room, plus 16x plus 28. Now I have a trinomial that I can factor looking for the factors of 28 that add up to 16. Well, I got 16 and 1. I have 8 and 2. And then I have 4 and 4. And I misspoke and I actually lost track of my thinking for a little bit. So what I'm showing you is that when you make a mistake like that, get actually to where you list them out. There's 1 times 28, 4 and 7, and then 2 and 14. Because when I was just trying to do it scattered in my head, I made an error. But when I got a little bit more strategic about it, it's like, well, 2 times 14 is 28, and then 2 plus 14 is 16. So the factored problem would be x plus 2 times x plus 14. And then here, unlike the last problem, I'll jump right into writing -2 comma, negative 14. And if I kept them in an ascending order, it would really be negative 14, comma, negative 2. Now here's the deal. Let's go back and let's check these in the original problems. So I'm going to do this for the last, for this one. So if I plugged negative 2 in, it's going to really be kind of silly to tax my working memory that way. So instead, I would get my calculator out, put negative 2 in parentheses so that I know that that exponent gets taken care of, and then add 16 times negative 2, and then I figure that, that would in a calculator end up giving me negative 28, which makes it match the right side, so we'd be good there. Now, that means that negative 2 is correct, but that doesn't mean that this is correct. So I'd have to check negative 14. And on purpose, I'm erasing these parentheses just to show you that you can recall that previous entry in your calculator and save yourself all the work and just go back and replace those variable values only. And that would also be true. Try this third problem on your own. Go ahead and pause this video to give yourself time to check it. Assuming that you paused and tried it on your own, I'll talk quicker through this one. You subtracted 27 from both sides and you're left with 0 on the right. And you're looking for the factors of negative 27 that would add up to 6. So that would mean that there would be 9 and 3. But you'd lastly have to figure out the negative and positive values would go that way. So here I'm going to write g as negative 3, comma 9, and you can check that in your calculator. Number 4 is just a preview what may come, but let's check it out. Here's 4, and the value, the equation is y cubed plus 4y equals 0. Now it's already solved with the right side there. So this would be a greatest common factor deal. From the left side I can pull y out, leaving me with y squared plus 4 is 0. Now the left part of the equation makes perfect sense. So I'm going to write y equals 0 and just box that. But now let's look over at y squared plus 4 equals 0. I look at this and it looks like one of those perfect squares that I could do something with, but I really can't, and that's because of this positive value here. So maybe I subtract 4 from both sides, and I'd have y squared as negative 4, which means you'd have to square root. And for now in math, you can't take the square root of a negative number, so we are going to write no solution down here for this part. And what that means is that when we summarize our work, we would only have y is equal to 0. So this would be the only available solution for that.